Hello, everyone. How's it going? All right, so my name is Jesus Alvarez. I've been a systems engineer for DHI for 3 years. I am also an open source contributor. I contribute to the Arch Linux project, and I contribute the ZFS packages for all the kernels. I've been doing that for about 5 years. You can see my code at github.com/demiser.
And I am Jesse Puls. I'm a developer by trade, have been doing development in a lot of different areas for about the last 10 years or so. And in the past year, I've been working in infrastructure things with DHI for DICE. You can also see my code on GitHub, but I'd ask that you not judge if you do. So I guess the first thing that we're going to talk about here is kind of what led us into this project. So the thing that we're doing is moving what has been around for a long time, sometimes upwards of 15 years, taking a bunch of on-premises applications and servers and moving that all out into the cloud. And the really important thing that we were kind of trying to manage with this was to make sure that we were doing everything in an automated way. So all of our infrastructure is stood up as code. We do all the buzzwords. We test everything as we stand it up out into the cloud, where we're making sure that we're repeating things and repeating them in predictable ways. And then we're also going to talk a little bit about kind of what's been successful through our journey and maybe some of the lessons that we've learned. Hopefully, you guys can learn from some of our lessons a little bit. So I guess an important thing to talk about is kind of what was the goals of our project going into it. You should always go into something knowing what you want to come out with the other side of it. So one of the really big problems that we were kind of coming up on was that we have a lot of servers out there that are old and have been around for a while, and they're going to have to be replaced, and that can be extremely expensive. And so kind of looking at how we wanted to modernize that infrastructure as we stood things up and how we wanted to upgrade and kind of move into the future with things. We also wanted to improve a lot of our application deployments and how they ran and the efficiencies in there, and just the overall stability of the entire system. And then the other thing that we really needed to do as a part of this was to kind of remove knowledge silos, make it so that if a person goes on vacation, we can still fix something if it breaks in production on that day or something to that effect. So we're going to go through and kind of talk about what the problems were that we were facing and the ways that we came up with to solve them. And for that, Jesus is going to go through a few things with you.
So, as I said, I've been with DHI for about 3 years, and in that time, there have been many problems. And this is mostly due to the fact that a lot of the changes that were made to our infrastructure were done manually. So if we needed to scale out an application or something, we would clone the VM, and all the configs and changes that were on that cloned VM also went to the new one. So over time, the changes piled up, and eventually we had servers that had things that shouldn't have been there. And also the distribution and the application itself was kind of out of date, and it was just a big mess. So the solution to that is that we started implementing our infrastructure as code using Terraform and Puppet. This allows us, so we use modules in Terraform and Puppet, and we can share those modules across teams and brands within DHI. So in the process of re-implementing our infrastructure as code, we found that we had configurations on the host that we forgot about, and when we set up new servers, we discovered like, oh, we're missing this config. So let's add it to our module. And now, as a result of that, the entire organization has a better understanding of what our applications do and how they work. And then the other great thing about that is that we can reproduce issues in one environment and see them in another. So this has been very helpful for us as we scale our app. And the other great thing about it is that developers can contribute back to our infrastructure as code, and it's open pull requests, and we review them, and gives them a greater sense of ownership across the infrastructure and the application. So one thing that manual changes lead to is that everything's always broken. Environments were unreliable and fragile. Deployments were unreliable and fragile. So that led to people not trusting, being trained to not trust the deployments and the infrastructure. So if something went wrong, they would always call DevOps and say, this is broken, and it's not our code, it's your guys' fault, fix it. So, you know, and that led to quick and dirty fixes just to get things working again. And those quick and dirty fixes usually stayed with the server. And as I said earlier, we cloned the machines and it just piles up. So one solution that we did to fix that problem was that we implemented tests on our infrastructure. And so the test acts as documentation for expected behaviors. Test allows us to make sure that when we modify things, they are in an expected state. A breaking test will lead to a conversation on whether our expectations should be changed or that we need to change our test. Testing modules allow us to ensure that they continue to work for all use cases, past and present. Another issue that we have is that everything took too long. So in 3 years at DHI, I've been the release engineer. So every Wednesday night we got together, after work of course, and 30 people would be online waiting for me to finish deploying the code. And once I finished deploying the code, usually with a series of bash scripts and Jenkins jobs, we somehow managed to get code to production. And so once I finished, then the QA and the devs would start testing the application in prod. And this, well, just doing PVT smoke testing. And this usually takes around 40-ish minutes, but if we find a defect, we have to start the process all over again. And it can take up to 2 to 3 hours, which is, you know, on a Wednesday night when you want to be watching TV or something. And the other problem is environments do not match each other. So when we had a issue in our, so they test the application in our lower environment, and we go to prod, and there's an issue that's there that's not in our lower environment. We have to figure it out and get the changes in there. So the solution to that is automation. So if we want to scale out our servers, it takes minutes rather than days or weeks. Developers can open pull requests to our automation and create the thing they need themselves, and then we, as our team, reviews the pull requests to get the change out there. We spend less time doing hot fixes due to mismatched environments. The hope over time is to allow less people to be online for a production release. And if we find a problem in our environment or in our deployment, we write a test and have the test prove the problem and then fix the problem. In the future, we're hoping that DevOps doesn't have to be online for production release anymore. Oops. So another byproduct of manual changes is that too many things are known by few people, one person usually. If it breaks, you have to call them. If this person goes on vacation, you might have to call them. Nobody likes to do that. So the solution to that is teamwork. We create a code of conduct in our team that allows people to feel free to not know something. If they know something, we pair together to get them to introduce to the concept they're not too sure about. And this has created an environment where everyone pretty much knows all the things that go on in the infrastructure. And if they don't, then they're not shy to say that they don't know it. Another thing with pairing is that we do code review. And so the person, once they learn whatever concept they were having struggling with, we have them work on it together, and then we open a pull request and someone else reviews the pull request, and then we get that code merged.
So now we're going to talk a little bit about what tools we're using. So we're going to go through a little bit of a demo here, and before we do that, I kind of want to give you an overview of what you're going to be seeing a demo of. So the things that we're using to stand up and test our infrastructure is that we're using Terraform to stand up infrastructure, and then kind of a combination of Serverspec and RSpec tests that we've written to verify those environments as we stand them up. We're writing our Puppet modules using a tool called Test Kitchen. It is something that has been pretty highly used within the chef community. We're using it for our Puppet modules mostly because it's something that there was already some institutional buy-in with, and we wanted to have participation within the company. And so our choice was to go with something that people were already kind of familiar with and might enjoy using. We're using open source Puppet, and then we are using mCollective that we've set up using a tool called Coria that we are using to kind of manage deployments onto our servers and updates and those kinds of things. So what we're going to do now is we're going to kind of walk you through the process of creating environment. What we do is we use Terraform to define our infrastructure and manage the state of the servers and subnets and all of the things that you need for your environments. We use Puppet to manage the configurations on those servers in the environment. And then we will take the differences between environments and abstract those out into like variables and config files. And so our Terraform for each environment looks the same, but we have configurations that modify things like instance sizes and auto-scaling group sizes and all of those kinds of things that you might have vary between your environments. And then the last thing that we're going to show you, and actually probably the first thing, is how we write tests to prove those things. And so we go in, and something that we did as a part of this that was really important for us was to kind of, if we're going to write infrastructure as code, let's treat it as code. And so we wanted to test drive our implementations. And so write failing tests first. Prove that you understand the fail case. Make sure that what you're writing fails properly. So someday if it fails for real, it's going to fail properly. And then implement your changes to make sure that those tests do pass and that you can see that the things that you expected to occur did. So we do have kind of an environment already stood up a little bit that we're going to be using for this. The first thing that we're going to kind of walk through is a little bit of our Terraform and how we write Terraform to define a small environment and how we write tests to verify that those things exist. So what you see here right now is this is a set of our tests. This is to make sure that we've set up subnets correctly. So if you look at this file, what we expect to see in the subnets on our network are that we should tag them correctly so that we can find them when we're looking for them. We use tags to pull things out for scripts and monitoring and things like that. And so we want to make sure that we've tagged them properly. We usually tag with things like our environment name, stuff like that. We want to make sure that they're in different availability zones, because if we were to put two subnets in the same availability zone and then 1A drops offline, there was absolutely no use in having multiple subnets for that. So we want to make sure that we did it. And we want to make sure that we've assigned the right CIDR blocks to things. So when we migrate through environments, our dev environment is on a different network block than our production environment. We don't want to miss updating a config file when we create a new environment and have it accidentally put things into our dev environment when we didn't want it to. So we write tests to make sure that we've done those things. For the most part, it is where we're trying to catch the things that we're probably going to screw up at some point. If somebody says, hey, we need to stand up a new environment to do some testing, and I go through and I modify a config file that's 50 or 60 lines long, I'm almost certainly going to miss some of those things. And so these tests are there to catch those things. And so you see here then, which file is this?
Web server.
OK, so this is our file. This is our tests to verify that we've stood up our web server correctly. What you're going to find here is that we do find the web server, that we expect to find one of them. In this case, maybe this is our dev environment, we only have a single server, but when we go into our production environment, we might want to make sure we have 3 or 4 of them because we need to be able to handle some kind of load. We want to make sure that we've assigned the right instance type. You don't want your dev environment to cost you tens of thousands of dollars a month, but you also don't want to forget to update that instance type when you go to prod and have it fall on its knees as soon as a few people start trying to visit your website. We want to make sure that we've used the correct AMI. We want to make sure that the software that is supposed to be running on that server has opened up ports it needs and things like that. So if we pull up our actual Terraform file here, that's the basic setup.tf. What you see here is this is the definition of our environment. And this is all available. There will be a link here on the slide, but if somebody wants to download it and look through it, we've got kind of comments showing what all of the things are here. And it will all be available if you're interested in that. But what we do is we just kind of go through and create the things that you need to get a basic network stood up in this case. We have subnets, we have route tables, all of the boring things that you don't want to think about all the time. And then we have our security groups that allow access to our web server, all of that kind of stuff. And so Terraform allows us to define these in a way that looks pretty similar to JSON. It's readable. You can go through it as a person and kind of see what it does. And so let's go ahead now and run those tests and see what happens when we do that. And so you can see something that's really nice with using Serverspec and RSpec is that these are very human-readable tests. I can create a job that runs them, and anybody on the team, regardless of their understanding of the environment or how it should work, can kind of go through it and see what's out there. And you can see in a nice, pretty, things are green. If it was broken, they'd be red. And so this is just a real easy cursory. I can run these every time somebody changes something in the environment and make sure that we didn't accidentally change something that we didn't mean to. You can see in the second case down here, we run our Serverspec tests. What the Serverspec tests are doing is verifying that we've set up that web server that we showed you correctly. So in this case, we're making sure that we've installed Apache on that web server. We've made sure that port 80 is open, the service for Apache is running. If we restart the server, it's going to be running again. And we make sure that the example endpoint that we've put out there is in there. So we have just a simple plain text website out there right now. And we can make sure that that is there and is responding every time we change our environment. So that's how we test our environments. We're going to talk a little bit also about how we test a Puppet module as we develop it. So for our Puppet modules, we use, as I said, a tool called Test Kitchen. It's a cool tool, I guess. And what Test Kitchen allows us to do is define an environment that we want to test our module in. In this case, it's a Docker container that's running just kind of a basic Ubuntu 16.04 image. And when we run a kitchen converge, it will go through, it will install all of the packages it needs, that kind of stuff. It'll apply our Puppet module over top of it. And then we're able to run tests. So like you see here, we're able to run a kitchen verify, which makes sure that our Puppet module did what we said it should. And the really important thing to think about with these is that with our Puppet modules, we're testing the behavior of our module. So we don't want to test, if you have a web server that you're standing up that's going to host 100 different websites, you don't need to test 100 different websites as a part of developing your Puppet module. What you need to test is that if I define a virtual host, it's going to appear on my server. And so in this case, we have just one simple website defined in there. We've made sure that if we do define it, the config file will be created. It'll set the correct server name. It'll be listening on the correct port, those kinds of things. And we can show the HIRA data as well. So we use HIRA to feed data into our modules. And we can show the HIRA data for that test to show what it was basing that configuration off of. So in this case, we've defined a website there, and we have told it where its document root should be. It's pretty simple. We're just throwing a page out there onto the internet, more or less. And that's getting fed then into our module. So what we want to walk through here as a part of this is what happens when somebody comes to you with a new requirement. So somebody comes to you and they're like, that's great. You have a web server. You're hosting a website on it. I'd love to host 2 websites on it. So they come along. They tell us what they want. They say, we want our page to be just another really simple standard website that's going to be displaying the text, a second basic website. So what I'm going to do, as any good developer would, is I'm going to start copying and pasting the things I did before. I'm going to go in, and since we're test driving our code, I'm going to go in and I'm going to write a test for that. So if we flip over to the, oh, I got ahead of Jesus here. So we define this, but we're going to write a test, and we're going to see it fail before we actually apply that onto our server. So if we go into our web server, or I'm sorry, yeah, you were going to the right one. It's the server, the web server spec. Yep. So, like any good developer would do, I'm going to start copying and pasting the things I did before. I'm going to say, I've been asked to create this new page, and so I'm going to write a test to prove that it's not there right now. And it's not. You see we have a failing test. So we've seen proper failure. If that site goes offline, we're going to say that we cannot call that endpoint. And then I'm going to go do some more copying and pasting. I'm going to update my HIRA values and say and define what that second website's going to be. And so as a part of that, I'm just going to take what we did before. I'm going to create example 2 and tell it where its document root should be. And then we've just got a real quick, simple script here that is going to package this up, push it out onto our web server, and apply the Puppet module. And like every good demo, we have an error. What was that? Oh, did we get white space? Nice.
Where's the white space at?
Yeah, you need to go in one further. Thank you.
Oh, love YAML.
We should have had a linter on there or something, right? Excellent. Thank you. So now we can go run our test again, and we should expect to see it. But we still have a failure. We found that we made a mistake. Imagine that. So we have the ability to go in and look, and we can see what our problem was, that it did define the second virtual host in the test. But when it pulled back that content on the page and expected to see something, it didn't see what it should have. And so we're pulling back our first page for our second one. So let's go look at our configuration and figure out what we could have possibly done. And if you see here, we've made the mistake of copying and pasting too much. And we don't want our virtual hosts to all listen to all server names. And so we should be able to update that by just removing the server aliases and reapplying it. We did it this time. Look at that. And now we should be able to run our tests again. What have we done? OK, let's just pretend that one worked. I gave him bad directions, I'm sure. But so the idea there being that we can test to make sure that what we expected to happen did. And then when it does, we can guarantee that it'll continue to happen in the future. And so if somebody comes along and asks us to create a third one and we copy and paste badly again, and we leave a name in there for a previous site or something like that, when we run those tests, we're going to kind of catch those failures. And it's kind of there as a gut check for ourselves to make sure that we're not missing the easy things to miss. Because we all get in a hurry, update config files, and don't do a great job at it sometimes. So the other thing that we want to talk a little bit about is kind of how we manage our environments, because I think we do it maybe a little bit differently than some people that I've seen do. Something that we do to manage our environments is we manage everything in a Git repository, and every branch is a different environment. And so if we have configurations we want to move between environments, we manage that by merging. And so if we have added a new set of servers or a new type of servers into our development environment, we put things out there, we test them, we make sure that they're working, and then we're going to merge that code up into our pilot environment or our test environment or our production environment or wherever it happens to go next. Something that has really been helpful with that is if we were just copying and pasting values, a person has to remember these things. And so they have to say, OK, we went out to test last week. Since then, these 12 things are updated. And so we need to bring these configurations into these files. Since we do it through merging, a lot of times those values are different. But as we merge them in, we can look at what came in through that. And when we open up our pull request, we're going to see the Git differences and be able to kind of look through it and make sure that what we're bringing into the new environment is sane and it's what we want to be doing. The other thing that we do is we merge those tests through with every environment. So each branch in our Git repository has tests that go along with that environment. And those tests match that environment. And whenever we have new code brought into those environments, we rerun those tests. They automatically run based on Git commits, and we verify that every time somebody's changed an environment, our tests are representative of those changes, and everything is behaving the way we expect it to. We find a lot of problems that way. The way that we deploy things is we use Jenkins along with the DSL plugin to define all of our Jenkins as code. We can, at will, kind of tear down, stand up our Jenkins server, have all the jobs kind of magically appear after running the C job. That's something that's been really helpful for us. Everybody can run a Jenkins server locally to be able to test the integrations that we're building. A lot of what we do is automated through Jenkins. Our Jenkins jobs tend to do a lot of things for us. And so being able to run that locally and tinker with it is something that's been really helpful for us. And then we push that out into a code repository. We do a Puppet run on our Jenkins server. It pulls down all of the new things, and everything in the world is pretty great. We do orchestration using Choria playbooks. Choria is something that's been developed to kind of manage M-collective servers. The playbooks allow you to define kind of sets of tasks using YAML, which, as we displayed, we're really good at writing. And so we're able to define what should occur when we do a deployment. We have playbooks that will call something to do a Puppet run on a server. We have wait tasks that will wait for Puppet to finish running before it calls the deploy successful. And we can run things in batches and things like that that you can do through mcollective. Go ahead, next.
So we use Jenkins 2.0 for our continuous integration server. And we use the jobs DSL with pipelines. So you can see here that this is some of our pipeline. One thing that we noticed as we introduced this to the organization, that developers love seeing things divided into columns like this on the pipeline and stages. So they're pretty happy about that. So when our builds build artifacts, they push it to Artifactory, and our Choria Puppet orchestration takes those artifacts and puts them on all of our nodes. So the developers also like seeing the output and how that works. One thing that we do is we make all the deploys visible to everyone. So we have these showing on all our monitors in our various offices. So there's a lot of red here. It's still a work in progress. But people like seeing the jobs and seeing the status of them. If they see it red and they ask, like, why is it red? Well, but what can we do to help fix that? And so that helps the developers get more ownership of the entire orchestration. So what lessons have we learned? Get everyone involved early. It makes everyone feel like they have ownership of the code. They want to contribute to the infrastructure. They want to make changes to Jenkins. They want to, if they want to add a new job or get a new application deployed, they're very eager to go and make changes to the code because they know what it is and they see the tests and they know how to make those changes. Choose the right team. Make sure you have the right balance of knowledge on your team. Try as hard as you can to create an environment where everyone feels like they can ask questions and fail. Having people with different experiences have allowed us to have different perspectives. So when we started the project, I was mainly operations, and Jessie was a developer before she came on. And so kind of my experience as an operations person and her experience as a developer has made us both more knowledgeable on testing and operations and trying to merge the two. It's been very, very successful, I think. Not everyone has to be an expert in everything, but as a team, you work together and you figure out problems and get the solution.
So another thing that we learned along the way with this is that we really need to be flexible. So we came into this with kind of, as I mentioned earlier, that there were things that sometimes have been around for like 15 years. And so as we're kind of migrating those things out into new environments, and we're standing everything up fresh, which kind of has its good and bad points, we find a lot of things that do not work the way that people think that they do. And so we've had to do a lot of kind of reshuffling and changing things as we went along, figuring out how they actually do work and getting that kind of plan in place so that everything could be successful. The entire organization needs to be a part of that. That's really an important thing. I think that kind of as we began the project, we didn't have as many different teams through the organization involved in the project as we could have. And when they did kind of start coming on, there was a lot of questions around why we were changing things and stuff like that because they weren't a part of that decision. I think that's something that if the earlier you can get buy-in and people involved within your organizations, the more success you're just going to have in general on these things. And through test driving our things, we're able to discover a lot of problems quickly. This has been a really big thing. We don't have problems where applications aren't coming online and we don't find out until 3 weeks into working on getting that stuff out there. Because as we go along, we are making assertions about the things that we think should be occurring, and we're making sure that those are occurring as they go along. We've uncovered a ton of things that didn't work the way we expected them to, but we've found them kind of as quickly as we could, and so just that idea of fail fast. The other thing that we have really, I think, benefited from is automation. Automation is reproducible. So we can take things that are done through automation and we can do them over and over again. Something that Jesus mentioned earlier was we can reproduce problems. So we're always going to encounter problems, right? But if we're able to reproduce those problems, people are going to have a lot more confidence that when we fix them, that they're going to stay fixed, that we're not going to move into a new environment and have those exact same problems over again. If we're automating things, we shouldn't be seeing things reoccurring kind of magically. The confidence goes up over time. As things become more consistent, people are going to start to feel like they can trust the environments, and they're not going to have these questions of, can you go download this artifact and make sure that my code was included in it, because I'm not seeing the behavior that I expect here. And so that's, the confidence in that has been a really big thing, I think. So that is what we have, but we would love to answer your questions or show you more things. You can contact us both on Twitter, and we also have information there for where you can download our slides. And there's a microphone right there, so please come ask questions on it.
We also use Terraform and Puppet, and I was wondering kind of how you do with your provisioning, or where you draw the line between what's Terraform and what's Puppet.
So mostly all the infrastructure, like everything that's AWS related, we deploy with Terraform. And anything on the host that needs to be on the host, we do that with Puppet.
Where do the hosts come from? Do you use some kind of a provisioner with Puppet, or do you do like something like Foreman, or do you guys don't use Puppet Enterprise, I guess, right?
No.
So do you just have AMIs that use Terraform to bring those machines up?
Nope. So we have a Puppet master that manages the nodes, but the Terraform we execute either, depending upon the environment, we run some things locally, we run some things from our Jenkins server, and so that part of the infrastructure needs to exist before we can automate all the Terraform runs, but we can stand that up kind of locally from our machines then.
Hello. You said you're using Coria for the last kind of deployment piece, like so you're essentially using like mcollective package install your code at the end. Is that correct?
So we're using Hira to manage what versions of software to deploy, and then we're using just normal Puppet runs to update the versions.
Okay, so you're using mcollective just to call Puppet runs. That's it.
Yep. Okay. And then we have some custom developed mcollective agents that we've used to kind of assist along the way in the Puppet run. And so we have an mcollective agent that we'll call to make sure that a Puppet run has finished successfully, that services are online that need to be after it, and that kind of stuff.
Okay. Have you, how is discovery and, I guess classically using like mcollective as a deployment tool, you always had to worry about some machines maybe didn't report in that time? Like, have you solved that, or you're lucky they always are just there, or can you confirm they're not? Yeah,
so we have not had problems with that at all. You do have to have that initial check-in, but that occurs when a server stands up and checks in with the Puppet master initially, and it stores its local. We do the discovery of kind of throw the ping out there and let the mcollective servers respond. We don't use the. Go ahead.
We also run the Puppet agents in no-op mode, so they run every 10 minutes on each of the hosts, so they're always reporting back to the Puppet DB, and that allows mcollective to know which hosts are in an environment.
Okay, so you're discovering against Puppet DB then, or
right.
You're not doing like network discovery for it.
No.
Okay, and then you said for no-op, does that mean Puppet's not usually running?
So like Puppet's running, it just checks in with Puppet DB, mcollective, and that makes it so that when we do run a Coria playbook, Coria knows where to run the pipelines against.
Yeah, because I know I thought about that model too, where you change it in Hira and then you do your deployment, and then, so are you saying you're always running a no-op other times? Because I wasn't sure like how you do the change in Hira, and then some nodes are then going to start upgrading organically before you do the push.
Right, so when we update our version, and then in Jenkins we say, okay, we want to deploy this version, it'll go and run a Courier playbook on that thing, and then at that point, Puppet's not running in no-op mode. It's actually doing an apply.
Okay.
All of our upgrades are intentional, though.
Yeah.
We never actually do. We don't let Puppet run. We don't let Puppet run on its own. So we run in no-op mode. We have a Puppet board that will kind of show us the status of everything all the time, but we don't actually apply anything unintentionally ever.
Oh, so it's always tied to a code change. I mean, it's even simpler Puppet changes, like not just code deploys, but
It's not necessarily tied to a code change, but it's tied to a person saying they want it to run. And so, like, we could do a Puppet run that would update modules or things like that without actually changing any of our code around that. But we don't do the applies without clicking a button, basically.
okay.
If that makes sense. Does that answer your question?
Yeah, it does. I mean, and then you just kind of look in PuppetDB later and make sure what you wanted is actually there.
Yeah, I mean, so like I said, we do have Puppet board, and so we have that to kind of show us if we applied right now, here's what would happen. And then after we do a run, we can kind of see the updates along, you can go in and look at what actually was applied on that server. We can see that the status should change, and so if we had changes that were going to be applied to 40 servers or 30 servers or whatever it was, after we've done that run, that number should be changing, and it shouldn't be showing those ones as that they would change on a Puppet run again then.
Okay, cool. Thank you.
Thank you.
You mentioned using Jenkins pipelines. Have you looked at the Distelli products that Puppet released today, or do you have any interest in those?
I looked at it when they demoed it.
Yeah.
It looks interesting, but I haven't spent any time looking at it. I don't know
No,
if you have.
I have not either. I'll probably take a look after.
Thank you guys, by the way, for it sounds like you're doing a lot of very interesting things. I really like the way you're addressing drift, like just monitoring it and not automatically remediating it. It's a cool pattern.
Awesome, thank you.
I also really enjoyed hearing about some of your team's learnings and just some of your verbiage about the monitoring dashboard, like allowing more ownership for the dev side of the house. It's a really good way to shift left. I'm curious, something that I had a lot of previous frustration for at my old engagement on a large team, like kind of a central organization scaling Puppet across like multiple dev and ops teams, it kind of appeared to me like you guys were using a mono repo. Is that true? Like you just have like your whole environment checked into a single Git repository, or is it more modular?
So it's modular. We don't use a mono repo at DHI, but we do have HipChat channels and GitHub. So if someone's working on a Puppet module, we have kind of like ownership. Like, so this person is responsible for this brand, and I'm responsible for the Dice brand. So if someone makes a change that might affect something else, then we make that person aware, and then they're able to go and, well, of course we have tests for it, so we can run the tests and make sure, okay, all the things that we care about still work, it's fine. And then we open a pull request, and then we have the stakeholders review the pull request and make sure that nothing affects them, and then we merge the code and version it, and then that gets deployed to our infrastructure.
Are you guys using R10K, I guess?
Oh yeah,
for that?
yeah.
Right, and then do you use like a global fixtures or like an environment fixtures, or do you use Puppet files? Because that's something that was new to me. That really would have helped us. But the frustration came from when working on the trunk and trying to like have your own test environment. With a global fixtures file, like you'd have to change the versions of modules, and then like when you're trying to merge stuff from upstream, since it's fixtures for like everybody, it's changing all the time. I'm sure you guys maybe run into something similar. I'm curious.
We have not. So we use, with R10K, we have a control repo with the environment per branch.
Control repo, but
Right.
there was so much thrashing on the control repo all
Right.
the time. And
So-
so it just would like cause merge conflicts.
Yeah,
sometimes.
so we only have one Puppet master per brand. So DHI is a group. There's a few brands in the group, and so we use a Puppet master per brand, and then R10K we have an environment. So usually one brand doesn't use the same puppet master, so we don't have that conflict coming in. I think we tried it initially and it didn't work out so well, so we went back to just having one puppet master.
So on top of modularity across modules, and you also have modularity across environments, and then also per organization.
Right.
That sounds super helpful. I think
Yeah.
that's where a lot of our frustrations came from.
Right.
Sweet, thanks. That
Yeah, no
answers a
problem.
lot of my questions.
And I think something that's good with that is like, so we do that all with Terraform, and so if another brand wanted to stand up a similar infrastructure, we could give them things to do that. And so they don't, when we say that people are not using that right now. We don't have this like, vast, beautiful place where everybody's just using all the same things, but we could. If somebody came and asked us, hey, we'd like to set something up that's similar to yours, we could hand them things that would allow them to do that. And I think that would probably be at least my preferred
Because
approach.
earlier in the talk you were saying that Puppet was more of a unanimous thing, but then like you had all these other stuff that you were more pioneering, like using Korea and
Yeah.
et cetera, right?
Yeah, and
Cool.
there are differences kind of across the company, and people should be allowed to do that, right? You
Yeah,
choose the
totally.
thing that solves your problem the best.
Yeah. J. Paul Reed gave a great talk earlier about treating professionals like professionals, right? Letting them do their own thing. Cool. Thank you. Appreciate
You're
it.
welcome.
Thank you.
Thank you. All right, so it looks like that's it. Thank you, everyone. Yeah, so thank you everyone for coming. And again, my name is Jesus Alvarez. You can find our repo there with all the examples, and you can contact us on Twitter, Jesse Puls, and then Jesus Alvarez. Thank you.
Thank you.